In this channel, we conduct important experiments to understand what happens when we test some big ideas, like blowing things up or tinkering with black holes. Recently, we received a suggestion from many of you, exploring the idea of sending nuclear waste into space. It might seem like a straightforward solution to one of the challenges posed by nuclear energy, but as we delve into it, we discover that this concept isn't just bad, it's terribly bad, and the more you think about it, the worse it gets. So why is that? Let's begin by discussing what nuclear waste actually is. Nuclear waste is a somewhat vague term, and its classification varies from one country to another. In general, it falls into three main categories. First, low-level nuclear waste with 90%. This category includes items like tools, gloves, or discarded materials from nuclear facilities that may have low levels of contamination with short-lived radioactivity. Generally, it's considered safe for regular disposal. In the intermediate level, nuclear waste with 7%. This comprises materials that have been in close contact with a reactor core for an extended period, making them dangerously radioactive. With proper handling, these materials can either be safely buried or processed into glass or concrete and stored deep underground. Now, here comes the NEM information. The remaining 3% is where our problems really start. High-level nuclear waste is the most concentrated and dangerous type of waste, consisting of spent fuel taken from a reactor core. It's no longer just uranium. It's a mixture of various highly radioactive elements, incredibly hot and difficult to handle. This is what some suggest we should shoot into space. To put things in perspective, approximately 440 active nuclear reactors worldwide generate about 11,000 tons of high-level nuclear waste each year. Since 1954, we've accumulated a staggering 400,000 tons of this hazardous radioactive waste. Unfortunately, most countries are simply postponing the issue rather than dealing with it responsibly. Now, the idea of launching this waste into space might sound tempting. After all, space is vast, and there aren't any inhabitants there, right? However, there are a couple of significant problems to consider. Problem 1. The cost factor. While space travel is becoming more accessible, it remains exceptionally expensive. Just transporting something to low Earth orbit costs an average of about $4,000 per kilogram. To put this into context, it costs approximately $1,600 to mine, separate, and create 1 kilogram of nuclear fuel. Launching waste into space would suddenly make nuclear fuel for reactors much more expensive, significantly increasing the cost of the electricity they generate. Andy, if you like this kind of content, please subscribe. Launching the high-level nuclear waste from just one nuclear reactor would cost at least $100 million annually. To handle the high-level waste from all 440 operational nuclear power plants, we're looking at a staggering $44 billion per year for space launch alone. And this doesn't even account for packaging, transportation, and security expenses. But even if we disregard the cost, we're still faced with another daunting challenge. In 2021, there were a record 135 launches into space. If we were to repurpose all those rockets and fill them with nuclear waste, the total amount we could transport into low Earth orbit, the closest orbit above Earth's atmosphere, would be nearly 800 tons. To handle today's nuclear waste, let alone the hundreds of thousands of tons in temporary storage, we'd need at least 14 times more rockets. We'd essentially have to create entirely new space industries to meet the demand for massive, toxic space trash transportation. And this is where it starts to get even worse. Problem 2. Space is challenging. Our earlier calculations were based on sending nuclear waste into low Earth orbit, where we typically launch our rockets and satellites. However, filling this region around Earth with numerous containers of spent nuclear fuel would create a nightmare for managing space debris and avoiding collisions with satellites. Additionally, at this altitude, there's still a trace of atmosphere, causing a small amount of drag. This means that nuclear waste could potentially fall back to Earth within just a few years. Experts would consider this a massive problem. To avoid these issues, we'd have to launch our waste farther into space. If we aimed for, say, the moon, we'd either need many more rockets or much larger ones, making the whole process even more costly. For perspective, a single Saturn V rocket, like the ones used in the Apollo program, adjusted for inflation, cost about $1.5 billion per launch and could transport around 43.5 tons from Earth to the Moon. So we'd require approximately 260 Saturn V rocket launches every year, not to mention that using the Moon as a target for nuclear waste disposal would create a considerable mess. But what if we didn't aim for anything specific and just shot the waste in a random direction? Well, you guessed it, that's also a bad idea. Orbits are like loops, meaning they tend to return to their starting point eventually. So we'd need even larger rockets to launch the waste deep into space, which would of course be even more expensive. Even if we managed to send the waste far away, we wouldn't be completely safe. Earth might encounter these interplanetary containers in the distant future, resulting in a meteor shower made of radioactive dust. So, it's not a foolproof solution. Okay, how about we shoot it into the sun? Ironically, hitting the sun is quite challenging. Everything on Earth, including the rockets we launch, is in motion relative to the sun. To reach the sun, a rocket would need to cancel out all its orbital motion around the sun and fall straight into it. Strangely enough, it's easier to launch a rocket entirely out of the solar system than to send it into the sun. But both of these options would require the biggest rockets we've ever built. Problem 3. Rockets have their risks. Rocket technology has advanced significantly since the Apollo era, making them relatively safe. We've replaced the hazardous explosive fuels of the past with more stable mixes, such as liquid oxygen and hydrogen or kerosene. Some of the latest designs even land themselves for reuse. However, out of the 146 launches in 2021, there were 11 failures. If we were to use these rockets to transport high-level radioactive waste, there's a substantial risk of explosions on the launch pad or, in the worst-case scenario, disassembly at high altitudes or crashes at hypersonic speeds. Each failure would be equivalent to a mini Chernobyl, but instead of being contained under a concrete slab, the radioactive material could spread throughout the atmosphere. Radioactive particles could travel long distances carried by the wind. Most would likely fall into the ocean, but some could end up in inhabited areas, contaminating farmlands, food, or water supplies. In short, it's a recipe for large-scale nuclear disasters, which is far from an ideal outcome. And if you like this kind of content, please subscribe now in the channel. Nuclear waste is undoubtedly a cause for concern. However, the fear surrounding it and extreme proposals like shooting it into space highlight our difficulty in assessing risks correctly. Surprisingly, the largest amounts of radioactive elements, such as uranium and radon, are released by burning coal. Every year, the combustion of millions of tons of coal generates ash as a waste product, containing approximately 36,000 tons of radioactive materials. While this ash is less radioactive than high-level nuclear waste, there's significantly more of it, and it's often handled far less carefully. Some of this coal ash is captured by filters, but a considerable portion is simply pushed back into poorly contained mines, heaped into exposed piles, or poured into ponds that frequently spill into rivers and lakes. Living within 1.6 kilometers of one of these ash piles can increase your cancer risk up to 2,000 times beyond acceptable limits. This is in addition to other hazardous substances like heavy metals and the massive carbon dioxide emissions associated with coal burning. Strangely, despite these severe environmental and health risks, nuclear power plants often face more opposition than coal. The issue of nuclear waste and the reluctance to deal with it is undoubtedly a real problem. However, it's not an insurmountable one. There are effective methods for handling nuclear waste, such as deep underground burial and reprocessing some of it into new fuel. Regardless of how we ultimately address this challenge, one thing should be crystal clear. Shooting nuclear waste into space is undeniably one of the worst ideas ever proposed. We need to explore safer, more responsible solutions to ensure a cleaner and safer future.